everybody. Welcome to our session. Today, I'm Sandra from Google Security, and this is Jonathan, security architect from Shopify. Together, we'll be telling you guys about the new container security products we just announced today, binary authorization, and how you can use it to secure your software supply chain. So I'll be going over an overview for the product and how you can use it in your production environment. And Jonathan here will give you a live demo after my presentation. Then we'll take questions in the end. All right, let's get started. So what is one of the top questions that DevOps and security stakeholders at enterprises have on their mind? What is running? Enterprises run thousands of services in their production clusters across multiple environments. And oftentimes, it is very difficult to keep track exactly what is running, and let alone how to apply centralized, consistent control over this software. Data leaks, security incidents, data breaches are on the rise, and many of those are caused by bad code running in trusted environment, having access to super sensitive data. So code is the weak link in many enterprises' security story. I've seen a lot of users that invest a lot of energy and effort for configuring the perfect access control policies to make sure only trusted account can access sensitive data, as well as pushing production code. This is good, but not enough, because as organizations grow, as the number of applications grow, as the number of employees grow, it becomes increasingly difficult to keep track of what can deploy in the production environment. What do I mean by that? So take an example. This user has a bucket of customer credit card information in production, super sensitive. And he has configured his access control policy to make sure only his production applications and a couple of trusted admins having access to this bucket of credit card information. But because of the application is VM-based, it is very difficult to build new versions and push new releases of this application. So it ended up running for a long time. And while it's running, different roles from different part of the production, from the organization needs to do things to the running application. For example, security engineers may come and patch, apply updates when things becomes outdated. Admins may have to come and restart the software when it gets stuck. Software engineers may have to come and manually make adjustment because new requirements get published, things change. Before you know it, you have a number of people and a number of paths that can apply changes to production software. With this fairly broad attack surface, a attacker or rogue employee could come by and slip in a piece of bad code to one of the changes to the production software. Now, voila, you have a security incident. So you may think that, well, that is legacy software for you. I plan to update all of my production infrastructure to use containers. I am good, right? Let's take a look. So this user has a container running in production. It is true that containers refine the software supply chain. You don't have a number of people apply changes to the software directly anymore. Instead, developers have to rebuild and repush a container in order to apply any changes to it, because containers are immutable. So now organizations have a centralized choke point where all changes to production deployments are applied. And a lot of them take advantage of that to bake in streamlined security controls and test to make sure that all the production changes are up to snuff. Things like making sure it's built from trusted sources, making sure it passes all the unit tests, making sure it clears vulnerability scan, making sure static analysis don't find any fault with the code, and it has been manually okayed by a quality control engineer. It is all good. But it still does not fundamentally change how deployments are controlled. It is still account-based deployment control, which means that if you have an employee or attacker who stole the credential of an employee have access to push code in production, they could still just bypass all of those streamlined CI/CD controls and push a untrusted piece of code in production directly. Now, that is where binary authorization comes in play. Binary authorization makes sure that only properly signed containers are deployed to the Kubernetes engine. It gives you a tool to define policies around what can be deployed, in addition to who can deploy, addressing the weakness in account-based deployed control mechanism. So let's take a look at how it works. Users have a piece of code that he has a CI/CD pipeline set up, run the code through a set of required tests and controls before pushing to production. Binary authorization integrates with the CI/CD pipeline by having them producing a signature as the image passes through the individual stages in the pipeline. So a builder would sign a container that says, I'm the trusted builder. I am the one who built the container. Test will sign a container that says, this container passed my test pipeline. Vulnerability signs the container when it doesn't find any known existing vulnerabilities on it. Analysis, QA engineers put their respective signatures on this piece of image. So by the time the image comes to be deployed to production, binary authorization is integrated into the GKE deploy API that will look at the signatures that are produced by the different stages in CI/CD pipeline, compare that against customer-defined policies on what can deploy in production, and then make a deploy decision. So now if you have an employee with access to push code to production, comes along to push some untrusted code, it would fail because the image would not have the required signatures on it. Now you have code-based deployment controls. So at a high level, this is how it works. And we've worked with design partners such as Shopify to make sure that it can properly integrate into your existing production setup. We have a number of features that I'm going to go through with you today to see how you may to see how it works with your existing infrastructure. So first of all, you probably already have, if you use a container, you probably already have a CI/CD pipeline set up. You want to make sure that your process can be reused across a large number of production deployment. You don't want a separate repository, a separate pipeline for each environmental application that you build. Binary authorization accommodates that by define policies at the runtime environment level. What do I mean by that? Let's say you have two clusters on GKE, a prod and a dev. For the production environment, you want to make sure that an image has to be signed off by all the required CI/CD stages before it can run, because it has access to live customer data. But for dev environment, you want to maintain developer velocity. So as long as an image has been built properly, has passed the unit test, it's good to go. There are differences in deploy time policy for this environment, but they can still use the same CI/CD setup. For a production deployment, it has to go through the entire CI/CD pipeline, clear all stages before it can be deployed. But for the dev environment, you have the options of build it, test it, take it out of the pipeline, deploy it then and there. Or if after running in production, in dev environment for a while, you're like, this container is good, I'm going to promote it to production. You don't have to duplicate any of your CI/CD setup. You can just push it through the remaining required test. And now it has all the required signatures. The same image that was deployed to dev can now be deployed to production. So you can maintain a centralized, shared CI/CD process across all of your environment, which is easier to manage and more secure. binary authorization integrates with the centralized metadata store hosted by Google Container Registry. It's called Container Analysis API. We've also announced this product today. Container Analysis API is designed to be the one-stop shop for all metadata associated with a container, so that a centralized stakeholder can, if he has questions about a particular container that is being deployed or that is running, he can go in and check to see, what are all the information, what are all the things I know about the container. So as a container goes through its build processes, for example, the builder would generate a build record indicating what are the source that was used for this container, what are the packages that was included, when was it built, who built it. Container goes through test. The tester can write a standardized metadata about the test result, goes through scanner, standardized metadata around vulnerability findings for the image. So by the time the image comes to deploy, controls such as binary authorization can take a look at all the metadata that are produced in the Container Analysis API and apply policies, apply controls to determine what can deploy in production. So binary authorization's signature format is just one of the metadata that Container Analysis API supports. The Google engineers has also published an open source standard for called Graphias for this Container Metadata Analysis API. It uses the same metadata format and uses the same API format, so that you can collect and produce and collect this information for your on-prem environment. Binary authorization also published a Kritis open source project, which is a open source implementation of deploy time enforcement with Kubernetes, very similar to binary authorization, which combined with Graphias, you have the building blocks to implement a similar enforcement flow for your on-prem deployment, similar to what we have here for Kubernetes engine. If you use Google GCP tools such as Google Container Builder and Google Container Registry Vulnerability Scanner, there are a set of metadata that's already produced for you. So if your code is built by Google Container Build, it will already produce a verifiable build record for you for every container that it builds. And today, that is happening is stored in the Container Analysis API. Similarly, when you push an image into Google Container Registry, it gets scanned by the Vault scanner, which is also announced today, and it will publish a vulnerability findings. Now, one of the most common use cases that we hear from customers is, I want to be able to gate deployment based on build and vulnerability information. The tricky thing with that is, every organization has a different definition of what is acceptable in a build and in a vulnerability findings. That is why we give you a tool, an open source signer, that you can use to define what your organization's requirements are for build and to sign a build and vulnerability record. So the way it works is the user will take the signer, apply their own custom configuration that they say things like, in a build record, I will only sign a container for to be okay to deploy if the source comes from these following 3 repositories. Or I would only sign a container to be vulnerability state ready if it does not contain critical vulnerability findings. And when that happens, the signer issues an attestation using a customer-provided key. By the time the container reaches production, binary authorization will look up that attestation, because the user would put that in the policy to say, I would require this attestation, and enforce to make sure only images with proper build and vulnerability finding records can deploy to the production environment. We also understand. So far we told you about how only properly signed images that are built in-house can be deployed to your environment. But we also recognize that not all images people run on their production environment are built in-house. There are popular third-party images such as Nginx and Redis that a lot of customers deploy. But it's also a common source of vulnerabilities in many enterprise environments. So to address that issue, we support image whitelist in the policy, in binary authorization policy. So a security stakeholder could say, I want all of the Nginx instances deployed in my organization to be the up-to-date, vulnerability-free one that I deemed OK. So he would put that in the policy. And when an employee comes and try to push the latest secure Nginx image, the digest will match, and the deployment will go through. But if somebody tries to push the outdated, vulnerable version of the same third-party image, it would fail and generate the audio log so the security team can review this incidents later on. And therefore secure your deployment environment. Binary authorization integrates with Kubernetes master to make sure it can apply verification, apply the policies to every single deployment that goes through your to your production project. So when a deployer comes along, the deployer could be a human, could be an automated pipeline, does not matter. It sends a request to Kubernetes master that says, I'm deploying digest foo to cluster bar, which then would forward this request to the admissions controller, which is part of the Kubernetes master. If this project or if this cluster has binary authorization turned on, admissions controller would forward this request to binary authorization, which then would go look up all the signatures associated with it, come back, verify those signatures using public keys defined in the policy, and return a verification decision. Once Kubernetes master receives the decision, it can then go ahead, either block or allow the deployment. But we understand that production emergencies do happen. What if your things are on fire, so you want to push a non-conformant change? We allow that. It's called break glass. So again, deployer comes along, says, production is on fire, I have this quick fix here. Let me just push it through. I will specify break glass flag, and the request will reach Kubernetes as usual, go through the whole verification process. Binary authorization says, no, this is not conformant. But Kubernetes master will say, I'm overriding it, because break glass flag is turned on. And this would generate an audio log, so the break glass deployment event would can be reviewed later on. So this is binary authorization. Coming soon to beta, which is announced beta today. The code will be available shortly. Hopefully, I've convinced you that code-based deployment control is more secure than account-based deployment control. And binary authorization would provide that for our Kubernetes engine. We will support runtime policies associated with the runtime environment at both project and cluster level, so you can define enforcement at different granularities. We'll have integration with GCR vulnerability scanner as well as the Cloud Container Builder, so that you can apply deploy policies based on vulnerability findings and build information. We'll support whitelisting trusted third-party images, so you can have standards across your organization on what third-party image to run. In case of emergency, break glass. We'll integrate with IAM on audio logging, so that you can review failed attempts, break glass deployment events later on after the fact. We also want to make it really easy for you to integrate this into your CI/CD pipeline, to make it easy for you to write binary authorization signatures for your image. So we'll have partner support from popular security tools such as Twistlok, popular CI/CD tools such as CloudBees and Jenkins to make it easy for you. Last but not least, we'll have open source reference implementation for Graphias and Kritis. So you have the building block to implement similar security controls for your on-prem deployment. All right, so that concludes the overview of binary authorization. And hopefully I give you a taste of how to secure your software supply chain using this new product that we've announced. Next, we'll hand the floor to Jonathan. Jonathan will show you guys a demo on binary authorization work in action and combine it with other security controls to secure Shopify's production environment. Jonathan.
Thanks, Edward. Cool, look at that, it works. Demo's done, thanks. Yeah, I wish. So, hey everyone, my name is Jonathan Pulsifer, production security engineer at Shopify. Before we get started on this, just want to go over what our production infrastructure looks like at a pretty high level here. So if you are a developer at Shopify and you have a repository that contains code and you want to turn that into a service, you interact with this tool called Services DB, which is where all the robots live. So we're going to create your production identities and these sorts of things, your Kubernetes namespaces, and all that. And the automation, like a build kite pipeline, will also be added for you. So build kite is not too unlike Google Cloud Container Builder, and we're going to run through what that looks like today. After an image is pushed up to GCR, we're going to deploy it with a tool called Shipit and a gem which we've open sourced called Kubernetes Deploy. So please go check that out. Once it hits Kubernetes, there's a lot more automation and magic that happens there with our cloud buddies. Our cloud buddies are the name for our custom Kubernetes controllers that help keep our cloud fluffy at Shopify. And further to that, we use a number of other GCP services to help make our cloud go. So the demo that I have for you today is a PCI compliant demo. As a security person, moving our compliance environments into GKE has been a large project that we've been working on. And so we've had the need to create these policies which help us remain compliant. So Google Cloud Container Builder comes PCI certified out of the box, so we don't need to worry about that. And we get some added stuff for free, like Sandra mentioned, like the verifiable build records and vulnerability findings. So given that, we've built a tool called Voucher. So this slide is very similar to the ones that you've seen earlier, where we've taken that open source signer and, well, we've built something. So I'd like to show you what that signer looks like, hopefully in real time. So what we're going to do is run through 2 demo attestations or signatures that are created that are going through these integrations that Sandra talked about earlier, containing no vulnerabilities and actually verifying the build record. So I'm going to flip over to my build triggers. What I've done here is I have 2 source repositories in Google Cloud. One is called bad and one is called good. And so we're going to run through those, build some containers. What they're doing is they're triggering on each new Git tag that's pushed. So we're going to change the Docker files up. We're going to push some tags and we're going to see what Voucher has in store for us today. Maybe. So because live demos are super fun, I actually haven't recorded any of this. So I'm going to try to make it. And look at that. It's super quick. That's awesome. So I'm going to explain sort of the lay of the land here. In the bottom left pane, in the bottom right, the bottom panes are the containers and the source repositories that I talked about. On the left-hand side, we have our good container, and the right-hand side, we have our bad. Voucher has been built and is listening in the top pane. So we're going to go through and show you these Docker files for a good container. We're going to make some changes to it just for funsies. So instead of echoing hello, we're going to echo hello too. I just want you to note the from directive that we're using here. So Alpine, as hard as it may be to work with in production, actually does not come stock with any vulnerabilities. Fingers crossed that nothing's changed since the last dry run. So what I've done is I've just changed the Docker file. I'm going to add the Docker file. I'm going to write a little commit message and say, hi, next. I'm going to tag this with next demo, and I'm going to git push and git push tags. Now, hopefully, when this is up, what's going to happen is every time that a container builder finishes a build and puts it into GCR, it's going to create an event on PubSub, and so I'm listening to that build notification. So Voucher should, fingers crossed after that build's done, pick that up and do its thing. So while that's happening, I'm going to show you the second Docker file. I just want you to notice the from line. Don't mean to trash Ubuntu, but like, come on, right? Fun. So we're just going to do the same thing. We're going to change our Docker file. We're going to add it up. We're going to write a commit message, and then we're going to git push and git push tags. Oh, I didn't tag it. Darn. Good enough for government work anyway. So hopefully that's all done now. So I'm going to walk you through this output that we have from Voucher. I tried to make it as pretty as possible for the demo. So here's what happened. So you can see that there's a build event that we've inserted that, this new container, this new image with the SHA. And what it's doing is actually going to go through and pull the container analysis API to see if it's noticed that any new images have been pushed and see if it's going to run through any analysis. And we can see that it's found no discovery, so it's going to wait for some, and it found that the vulnerability scanner is going to go through and do its analysis. That actually finished, and no vulnerabilities were found in this container. At the same time, it's going to run the provenance check. The provenance check is verifying that the image in the verifiable build record, its checksum actually matches the images that we want to deploy or that's actually hit GCR. So we're actually just making sure that the artifact has maintained its checksums all through the pipeline. Snake oil is the name of the check that we made that ensures that containers contain no vulnerabilities. So we can see that this passed because Alpine is pretty cool with that and actually worked as expected. I just quit Voucher here because we're done with it for now. But we see the second build event for our bad container, and we see it's doing the same thing. It's waiting for analysis, and oh, look, it found 32 vulnerabilities in this container. And just, for fun, we decided to surface one of the critical vulnerabilities. So we have a critical vulnerability in glibc 227, and there's a CVE that's associated with it. So this makes sort of SecOps a little bit easier when we have to determine which vulnerability is actually present in an image. So we can see further, after all those checks have been done, we can see the attestations are being created. So in the good container, we have 2 attestations created, 2 signatures for provenance and for snake oil. And we see that this attestation was created for provenance for the bad container, but actually failed because it contained vulnerabilities. And we don't want any vulnerabilities in the images that we deploy today. So earlier we talked about this policy. So we're going to take a look at the policy that we have set up for the clusters in our project. So this policy for binary authorization contains some whitelisting, because if we didn't whitelist these 3 repositories, my Kubernetes cluster wouldn't start on GKE. So what I've just done is just globbed every image inside of those GCR repositories has been whitelisted for the purposes of the demo. Please do not do this at home. Okay, so I'm going to run through the rest of this. We have some cluster admission rules. So earlier we said that we can specify a policy on a project level and on a cluster level. So we're going to try to demo both of those today. So in the cluster admission rules, I have running in Canada or North America, Northeast 1, a test cluster. An evaluation mode require attestation. So what this means is that any image that deploys a binary authorization is going to match these attestations. And you can see that they're named provenance and snake oil, just as we talked about. For all the other clusters running in this project, we only want to make sure that it's built by a trusted identity and that the image actually was validated. So, moment of truth. We're going to try to deploy some images. We're going to grab our good SHA that passed, and we're going to kubectl run good times. And we're going to try to run the thing. So what we're going to do also, come on, hey, look at that. Then we're also going to grab the bad SHA, the one that failed, and we're going to kubectl run bad times. We're going to deploy those. So what do we all expect would happen? Well, I would certainly expect, based on my policy, to have 1 good times deployment and no bad times deployment. So let's check it out and see what happened. So we're going to get some pods, and sure enough, only 1 good times pod is running, because both attestations have been created based on the policy that we created for our project, and in this specific case, our cluster admission rules. So, cool, but what does that mean for a developer? How can we get any sort of actionable feedback? Where does this live? How did that fail? I'm a command line person. So I'm going to get the replica sets that have been created here. A deployment in Kubernetes is like the highest level abstraction, which creates replica sets, and further to that creates pods. So we've created the deployment object and said, hey, cool, we want this container to run. Then it created a replica set, said, hey, cool, we're going to try to start this pod for you. You can see that bad times has one container desired, but none are ready. So we're going to see what happened with that. Boom. Talk about error messaging. So for those who don't know, Kubernetes controllers are on like a TLDR for loop, so it's just going to keep trying to do this thing over and over and over again. And every time that it tries, we have an error creating the pod. It's forbidden because it's an image policy webhook backend denied one or more images, right? So every time that it gets deployed, there's some shenanigans and webhooks that fire around that help this do its thing. It was denied by the attestation authority. We cannot find any snake oil attestations for this image, such that it failed. Neat. So, what about on all the other clusters? Just to prove that the policy works, I created a YOLO cluster in here, and what I'm going to do is I'm going to try to run the bad times image, the same one that was attested earlier with voucher, and fingers crossed, it should deploy to my YOLO cluster. Looks like it. Then we have one bad times pod running. So this sort of proves that the policy is sort of working as intended. Again, I'm just going to bring up that policy to show you what that looks like. Everything's YAML these days, such as the policy, and so it's pretty easy to read. It should be easy to read for not just security people, but for other engineers and operations people alike. It's important that technologies like this are human readable and easy to digest, or else we can't implement them properly. So, further to that, BinAuth is not just a command line suite. It does come with a fancy GUI now, thanks to our UX folks over here who made this the way it is today. So I put some human readable descriptions on our signatures or our testers, just to say what this is actually doing, such that, you know, if I name something willy-nilly like snake oil, that doesn't mean anything to anybody. But having a human-readable description there in a nice, pretty GUI makes it really easy for those other folks to understand and see what's going on. So that's it for my demo. Thank you very much. What I'm going to do is continue presenting a couple slides. So we hit beta today, which is super exciting, and now our website's live, so you can see it at cloud.google.com/binary authorization. We are going to be in the demo booth on the ground floor of Moscone South later, so if you want to come hang out with us, that would be awesome. And we are running some code labs for this. Sandra, I think there are code labs for this.
There's a code lab area in Moscone. There's a code lab area in Moscone South where you can go and get, it has machines set up. You can get some hands-on experience working through a code lab.
So, because we're a security talk and we like our security people, there's a lot more in container security happening here at Next. You know, that it's been the number one sort of topic these days, which is super exciting for me. But the one that we did really want to highlight is preventing the next major security breach down in the bottom right corner tomorrow at 1:15. That is the talk about the GCR vulnerability scanner. So if you want to learn more about how that works and talk to the folks who made that happen, tomorrow afternoon is where that's going to be.
All right.
Cool. So we're open for questions. Thank you. If there are any questions, there are mics actually on either side. So if you'd like to be recorded such that we can all hear you too, that would be sick. We got one over here on the left. Wait, left, other left, stage left. Is that a thing? Eeny, meeny, miny, mo. Rock, paper, scissors?
Hi. I guess I'll jump in. The binary authorization output that you were getting on the screen from the command line there, is that available in Stackdriver? Like, can we push that to our Stackdriver logging as well?
So binary authorization logs all the deployment events to Autolog, which pushes to Stackdriver, I believe. So you should be able to get that in Stackdriver without having to configure anything.
Okay.
There are two different pieces to this too, right? You have the actual Kubernetes replica set error as well, which would be just found in regular Kubernetes engine logs or other event logs, where binary authorization creates its own distinct audit logs in these circumstances. So like the image was blocked, you're going to have your regular Kate's events that's saying, oh, we can't start this pod because reasons. You can find that information there or in the audit log as well.
Yeah, the audit log is the audit log is basically the same place where GKE surfaces their audit log. So if you have that set up, you should be all good.
All right, I'll try. So is this something we can bring in, like, say, if we're not using GKE and we've got our own Kubernetes set up on some other cloud provider? Is this something we could bring in to use?
So we do have a open source reference implementation, as I mentioned. It's open source, so we'd love to hear your needs and get your contribution.
Okay.
But as is, yes, it is something that you can set up and to work with the open source Kubernetes. It's probably gonna take a little bit of configuration because it's not a hosted solution. You have to
Of course.
piece the things together. But
Okay.
yeah, we do have that.
I thought so. I just wanted to confirm. Thank you.
Yeah.
GitHub.com/Graphius/Graphius, GitHub.com/Graphius/Credes for both the reference implementations.
Thank you.
Hi, so I have two questions. The first one is, so there's no extra steps that you have to take, like at deploy time, for example. Could you use an orchestrator like Helm and still do this?
So every deployment that goes through GKE API, so you should just be able to deploy as usual. Shouldn't be any the deployment process for the vast majority of deployments shouldn't change unless you're deploying something that does not meet policy.
Okay.
Yeah, there are some integration work you have to do with your CI/CD pipeline to
Right.
produce the signature.
Okay, and then how would you apply the policy? Is it just a gcloud command?
Yeah, we have a gcloud command and a UI that you can define the policy in.
Okay, thank you.
I'm curious about where the private signing keys live, especially if you're using the open source stuff and can't use the integrated Google Cloud cryptography.
Yeah, so unfortunately, you'll have to manage your own private key for the open source version, as well as for the hosted version for now. We are looking at different integrations. We'd love to hear your requirement on where we should take this and make it more easier to use for you.
In the case of the demo, it's just PGP keys, and we have a tool called eJSON at Shopify that we use just to encrypt it and keep it in the same source repository. So GPG in a dream.
Are you planning to offer a hosted like voucher signing service, or is that something that we have to implement?
That's definitely something that we're thinking of. Come talk to me afterward, and like to get your requirements on that.
How does this compare to, they call it container signing, image signing with a product like Twistlock? Is this basically the same, or are there differences that haven't necessarily been called out?
No, we actually integrate with Twistlock. So if you're a Twistlock user and you have your scanner set up and you have your scanner policy set up, so while your image passes the Twistlock scanner, Twistlock would sign the image, which can then be enforced at deploy time on GKE. There are other types of products out there, maybe like Docker Content Trust, things like that, that also involves image signing, but that's more around the software distribution protection versus a sort of provenance enforcement. So the difference there is, while softwares are distributed in an open internet environment, it may get altered while it's moved from repository to repository, and signatures such as Docker Content Trust makes sure that the software has not been altered. It comes from a trusted source. But binary authorization takes sort of a slightly different approach, focusing on largely collaborative environment, which is enterprise organization, and you want to make sure that the software you deploy has passed certain tests that are hosted by you, that you have control over.
Okay.
Does that answer your question? Yeah, okay. All right, great. No more questions. As John mentioned, we're going to be at the demo booth around 2 o'clock. So if you want to come and check out and hang out with us, you're welcome. And thank you all for coming.
Thanks.